Hey guys, welcome back to AJ Tech. So today's video is going to be about the ultrasonic sensor, and we're going to go through how to set it up, how it works, and the code and everything. And like I always say on my live streams, if y'all have any suggestions or ideas, maybe we can try some of y'all's suggestions out if you put them in the chat. And let's get started. Alright. So let's start with what the ultrasonic sensor actually is. So I'll put it here. So the idea is that there are four main pins on this sensor. There's VCC, there's the trig pin, there's the echo, and there's the ground. As you can see here. And the idea is that for VCC, we're going to be connected to the 5-volt out on the Arduino. So we can put this to 5 volts. Then the ground will be connected, of course, the ground on the Arduino. And then the trig and the echo each have a purpose in this module. So let me zoom in. Alright. So the trig, what it does is pretty much it's like a trigger pin. And how it works is actually you turn it off, then on for like 10 microseconds, and then back off. And that's what sends the actual ultrasonic like sound wave. I guess you can imagine if these are like, you see these like things that send it, we can put them here like this. We're looking at like from a top view. So when you press the trig, it turns it on and sends these. You can imagine these are the sound waves. And then what the echo does is it's pretty much at a, we can make like a graph for it real quick here. So it's, let's say this is voltage versus time, and here we have 0V, here we have 5V as a max. So what happens is the echo is at 0 until the trig is turned on, and then once the trig is on, then it goes up to 5 volts. And it stays at 5 volts until the signal hits on the other side, gets back, like this way. Then it goes back to 0. So this right here, this time, tells us like the time it took for the signal to go, hit the object, and come back to the sensor. So out and then come back to the sensor. So we need to measure this time. Let's call this capital T, because that will tell us how long it took to go. Then what we could do once we have this time is, since we know that this wave is going at the speed of sound, we know that speed of sound, and you can easily look this up on Google, is 343 meters per second, I believe. And let's say we want this, by the way, T is in microseconds, by the way, like the output, or the output in the function that the Arduino uses at least. So if we know that the speed is 343 meters per second, and we have the time it took, we can easily measure the distance. That's how we're going to get the distance out of this. So what we do is actually, we want it in centimeters. So we would do some dimensional analysis, and then we would multiply this by 1 meter is 100 centimeters, since we want this in centimeters. And since we also want to account for it in microseconds, since the output is in microseconds, we can put 1 second over 10 to the 6 microseconds. Because then we have it, we cancel out the seconds, we cancel out the meters, we're left with centimeters per second, or per microsecond, which is what we want since this is in microseconds. And we get 0.0343 centimeter per microsecond. And then, since this is the distance going and coming back, what we're gonna do is then have this, multiply it by the time, and then divide it by 2. Since it's the time that, this is the time that it took to go and come back. Alright. Yeah, so since this is the time it took to go and come back, we divide by 2, and this will give us the distance. Alright, so this is the basic idea of what we're going to be doing. We can start to build the circuit real quick, and I'll go through the code. So what we're going to do now, like we discussed, we're going to have the ultrasonic. We can put this here. Just make sure you remember the pins. Alright. And now we connect, like we said, the 5 volts to VCC. So 5 volts right here to VCC, which is this pin right here. We'll connect ground to the ground pin on the ultrasonic sensor. And now I want to use pin 12 for the trig pin and pin 11 for echo. It doesn't matter what you use, but just make sure you know what you use exactly. We're going to need that later. So like I said, 11 for the echo, which is right here. And 12 for the trig. Zoom in. All right. And now this is pretty much the circuit. We can jump into the code. It's pretty simple. Circuit is pretty quick. All right, let me plug into my computer. And I can get us into the IDE. All right. So you can make your project real quick if you want to. And so first of all, we're gonna initialize the pins that we said we're gonna use. So I'm gonna be using pin 12 for the trig and pin 11 for the echo. So we're gonna make a constant int trig pin equals 12, and then const int echo pin equals 11. This just helps get like the project ready, the variables ready. And then we're gonna have the duration and the distance. Then of course we need to set the pin modes. So here we're gonna have pin mode of the trig pin. Since it's the trigger, of course, it's gonna be output. Since our Arduino is actually gonna activate it, turn it on, which will send the signal like we discussed previously. And then it will be detected anyway. So trig pin, we're gonna set it to output. And then we're gonna set pin mode of the echo pin to input. And the reason, like we said, because we're going to be measuring the amount of time that the echo pin is actually at 5 volts, because that will tell us how long the signal it took for the signal to leave and come back to the sensor. And then we're going to have this command called serial.begin. And this is what turns on like the serial monitor right here, and lets us use that to print like information into it, so we could check that inside of our serial monitor. All right, so that's all the setup that we're gonna need. Now in the loop. So as we discussed in the picture I drew, first we need to make sure that our trig pin is off. So we can write digital write trig pin, comma low. As we discussed in the previous video, low means at 0 volts, high means at 5 volts. Then we're gonna delay 2 microseconds using the delay microseconds command. I'm gonna write 2. Then we will start the process of actually turning on the trig pin for 10 microseconds, and then turning it off to start that signal for the sound waves. So here we will write digital write trig pin high, and then we're gonna wait 10 microseconds to make sure it went through, and then turn it off. Now once it's off, we're gonna measure the amount of time that the echo pin is in like the high state, aka how long is the echo pin actually at 5 volts, telling us the amount of time it took for the ultrasonic signal to go and come back to the monitor, like the module, I mean. So we will set the duration variable that we already made to pulse in echo pin, comma high. So the pulse then returns the amount of what you specify about the pin. So what I mean by this is we're saying at the echo pin, how long was it in the high state? So since we're interested in the high state, because some devices may be opposite, like inverted. Maybe they're at low, or maybe they're at 5 volts the whole time, and then once something happens they're at low, you would have low here instead. But for our use case, high will get us that amount that we need. And then using that distance formula that we derived, we will just put that here. So we'll have the duration times that 0.0343 microseconds per centimeter divided by 2 to account for the going and coming back. And then since we have the distance now, we can print in the serial monitor using the serial.print command. We can write the distance, or we can just write distance, and then we can print under it distance and then, or we can even do this if we want to, and then we can have the centimeters. And if we do println instead of print, it will create a new line between, like, it'll space the lines out instead of it just printing everything in one line. And then we can delay for 100 milliseconds between each measurement of the distances. Alright, and this is it. This should be good to tell us all the distances that we need. Let me switch my screen back so you could see the monitor. in the circuit, I mean. Alright, and let me compile and run. Oh, we cannot do the plus. So a quick fix could be just to have them in different print statements real quick. So let me do that real quick. And then we can put the print line for the last centimeter one. And that should do the same thing. We can get rid of this because of the type error. Because it should auto convert when it's by itself. Just compile again and make sure. Oops, forgot a semicolon. Alright. Alright, we're compiled, we're good. Alright, let me run. Alright. So let me show you all the code real quick again to make sure everything's good. So we just changed the print stuff because there was an error with the data conversion. And what you do now is you open the monitor right here to see the thing that you're printing, which is the distance in our case. And it should auto, yeah, if you press this down thing, it always keeps you at the latest like data. So now let me switch to the other screen so y'all could see. So you should see now the values changing as I put my hand. Let me bring this up. All right. So as I bring my hand closer, the values decrease, of course, as we would expect. As we move it farther, the values increase because the distance has increased. Thank you for watching. Don't forget to like and subscribe if you like my content. See you in the next one.